Hey, now I'm gonna show you guys something here. Okay, now if you got a mass in here that is M1, you got another mass in here, M2, another mass in here, M3, M4, M5. Okay. Oh yeah. Okay. Fine. The moment around or about the y-axis is gonna be you put capital M and you put a y. That means there's the moment about the y-axis. Well, it's gonna be m1 times x1. What is x1? It's the x coordinate of the m1. Okay, so m1 is located at x1, y1. Why? Because it's this distance right here, right? Plus m2, x2, plus all the way to m5, right? I'm gonna put ellipses here, plus m5, x5. And the same thing, the moment about the x-axis is going to be m1 y1 plus m2 y2 plus plus m5 y5. Now if you want to know, for example, let's just say that you want to find out from all these 5 particles the center of mass in the x coordinate, okay, the x center of mass, not the y. I mean, it doesn't matter if it's up here, down here, it doesn't matter. What matters is if it's in here or here or here, okay, or if it's in here, here. What matters is the x coordinate. If you want to find that, all you got to do is to get the moment about the y-axis and divide by the entire mass. M is the entire mass. And y is just going to be the opposite, okay? It'll be the moment about the x-axis and divided by the entire mass. So you're going to have the center of mass of x and y in here. Let me just show you if there's something else. If the moment of mass is not the moment of mass, but the center that you care about is not going to be the origin. If it's, for example, the point AB, okay, then all you have to do is to replace all these. For example, I'm just going to do this one. It'll be M1 X1, or yeah, X1 minus A, okay, plus M2 X2 minus A. To see the distance that X1 is from A, X2 is from A. So if you do that, you're going to find the center of mass about the point AB in the Cartesian plane in here. The way that it is right now, this way here, see, the way that it's being calculated this way, it's the moment of mass about this point here, about the origin. So we're going to do an exercise just to fixate this. Find the center of mass of a system of point masses M1 equals 6, M2 equals 3, M3 equals 2, and M4 equals 9. All right, located at 3 minus 2, I'm going to put a comma here, or a semicolon, I think it's better. The next one is 0, 0. The next coordinate is minus 5. I always have a hard time doing the 5. Minus 5, 3, and the next one is 4, 2. Okay, so this is where mass 1 is, mass 2, mass 3, right? So let's see, what's the total mass in the first place? Well, 6 plus 3, 9, plus 2, 11, plus 9, 20. All right. What is the moment about the x-axis? Well, it's going to be 6 times minus 2, right? Because about the x-axis, you care about the y-coordinates. So 6 times minus 2 plus 3 times 0 plus 2 times 3 plus 9 times 2. So this is going to be minus 12 plus 6 minus 6. Minus 6 plus 18 will be 12. The moment of mass about the y-axis, then you're going to care about the x-coordinate. So it'll be 6 times 3 plus 3 times 0 plus 2 times minus 5 plus 9 times 4. So it'll be 18 minus 12, no, minus 10, it'll be 8. 8 plus 36, going to be 44. All right. So if you want to know x bar, which is the x center of mass, it'll be the moment about the y1, all right, divided by that. So it'll be 44 divided by 20. I think you can divide this by, no, not by 10. 222 over 10, 11 over 5. Yeah, you can divide this by 4 only. The y bar, okay, is going to be the moment about the x1, about the x-axis divided by m. So it'll be 12 over 20. I think you can divide this by 4 also. So 3 over 5. Okay. Why is that, right? For people that haven't catched on yet, you got an x in here and you got a y here, all right? So the moment about the x is how much can you, for example, let's just say that you got a big seesaw, not a seesaw that's linear. We're talking about a plane that's a seesaw, okay? But we're not considering all the points of the plane. Magically, just consider this point and this one and this one. So you want to know how much around the x-axis this mass can do, all right? Let's just say that we have gravity pushing into the gravity is pushing into the paper or into the screen here, okay? So the gravity is going in here. It's going in your direction. So what are you going to do? Well, this part is going to go down. I mean, all this, because this is a plane, all this part's going to go down and this part in here is going to come up, okay, out of the plane. This will go into the plane and this part will come out of the plane, out of the screen, for example, because this is a plane, and so you have a plane on top of the plane, which is a screen, and you're just going to do this, okay? You're going to rotate. So what is the power of this thing? Well, it's going to be the mass times the y-coordinate, because the y-coordinate is the distance from this point to the x, okay? That's why the moment about the x, you care about the y-coordinates, and the moment about the y, you care about the x-coordinates, all right? Now, what's going to be the center of mass in x, for example? Well, it'll be the moment of y divided by the total mass, okay? Because it's the power of rotation of these 3 points. Don't forget about the other points. These 3 points, it's the power of rotation about the y. So you want to know what's going to be the center of mass. So you see that the center of mass is not 0 in the x-coordinate. The center of mass is not going here. The center of mass is 11 divided by 5, which is a little bit over 2, okay? So let's just say that you have, for example, this is 1 and this is 2. If you go a little bit to the right of it, kind of like here, okay? What it means, guys, is that you have this plane, okay? Let's just say that you can drag this whole plane horizontally, okay, perfectly to the left until this thing here is in here. If you do that, because this is the center of mass, okay, then the whole plane is going to be, how can I explain? The whole plane is not going to rotate like this anymore. It may still rotate around the x-axis, but it's not going to rotate around the y-axis, okay? Now, if you leave it like this, because the center of mass is way over here to the right, it's like you're having an unbalanced seesaw, okay? It's like instead of having a, let's just say that this is a seesaw, instead of having a point here, you actually, because this is the center of mass, consider that this is the center of mass, so I'm putting the pivot over here. Of course, this thing is going to come down here and it'll come up there. Okay, but instead of just thinking of a seesaw, just going in this direction and in this direction, you're thinking about a plane now. A plane that can rotate about this and it can rotate about this. So you have a bidirectional or a bidirectional seesaw, right? This thing can go into the page here and out of the page here, or it can go into the page here and out of the page here, or it can also go into the page here and out of the page here, or into the page here and out of the page here. So it's like this. It's a plane that can rotate either way, right? So that's what this is about. So you know that this thing here, let's just say that you have gravity going into the page, this whole part is going to go into the page and this part's going to come out of the page. All right? Now, the y is also 3/5, so it's positive. So you know that 3/5 is not even 1, so let's just say that it's kind of like here, okay? So if this point in here, this dotted line that I'm doing here is the center of mass for y, if you bring it down so that the center of mass is exactly on top of the x-axis, it's not going to rotate. The way it's going, this whole thing here will go into the page and this is going to come out of the page. All right. Now, of course, because you see the cross section between the center of mass is over here, okay? So what's going to happen is that you're going to have the influence of the moment about the x-axis and the moment about the y-axis working combined. So what is really going to happen if you just let this go and you put gravity going into the page? This thing will go into the page and this thing will come out of the page. That's what's really going to happen, okay? Because you can see that the moment of x is here. The moment of x. The center of mass is here, all right? So, yeah, keep that in mind. Okay, now I'm going to give you something here, for example, density. Density is being represented as the letter Ho, which looks like an italic P. Okay, it's a Greek letter. I think it's written like this, Ho. But I'm just going to put a P, okay? I'm just going to put a P. I shouldn't do that, but I'm not going to do it italic stuff. No, it's just a P. I'm going to consider this the density. Or I can just do D, right? So what is density? It's mass divided by volume. But when you're talking about a plane doesn't have a volume. A plane only has an area. So it'll be the linear or the laminar density, which density is going to be the mass divided by the area. Okay, so if I give you an area and I give you the density, you're going to be able to find the mass. All right. Now, let's just say that you have something like this. Right? You got some kind of laminar thing here. You got a plate, okay, a metal plate like this. All right. So this thing here is gonna, I'm sorry, this is g of x and this is f of x, okay? Now, how do I find the entire mass of this thing given a density? Let's just say that the density has to be the same everywhere. It cannot be more dense in here and less dense in here. The density has to be uniform, okay? So the density equals mass divided by the area. How do I find the area of this thing? Well, we already got to that point, guys. If you integrate this with respect to x, okay, you're going to do one thing here. You're going to get this distance plus this distance, plus this distance, plus this. So it's the infinite sum of infinitely narrow rectangles, vertical rectangles in here. Okay, so what is going to be the mass? I mean, what's going to be the area? The area equals the integral of f of x minus g of x dx. This is the area. So if you multiply the density in here, this is going to be equal to the mass of this thing. Okay, that'll be the total mass. Okay, because why do I want to know the mass of this? Because pretend that you want to find, well, in order to find the x bar, the center of mass in x, you have to do m of y divided by the mass. So you're going to need this mass. Okay? And what is m of y again? M of y is the power of rotation of this plane, okay, around the y-axis. Now, if you're integrating with respect to x, okay, what you care about is this vertical thing here. Oh, it's not vertical, but pretend it is. I'm gonna do this. Okay, now it's perfectly vertical. So you want to find the mass of this infinitely narrow rectangle. What do you do for this one? This one is gonna be f of xi, okay, minus g of xi. You gotta pretend that this is xi. This is xi. So there you go. All right. Now you're gonna have this times dx, because if you do just f of xi minus g of xi, you're really literally you're not gonna have a rectangle. You're gonna have a line, a vertical line. But a line is not an area, and you need an infinitely narrow area. So you have to multiply this thing by dx, okay? An infinitely small x in here. All right. Or, you know what you can do? You can say delta xi, where delta xi is approaching 0, all right? So if you do this and you multiply this by the density, now this represents an area and this represents the density, which doesn't change. You gotta assume that the density is just, okay? Now you have a mass because you have an area here and you have density here. So multiplying these two, you get the mass. Is it the total mass? No, this is going to be equal to the mass I. Okay, the mass of this thing here, I'm going to call this I. The I infinitely narrow rectangle. Okay. Now, there's something else too. What is going to be the power rotation of this around the y-axis? You got to consider the distance, right? From this to the y-axis. So all you got to do to find the moment about the y-axis for this rectangle is multiply this by xi. Xi is going to be the coordinate, right? So if you multiply all these things, it'll be mi xi, which is going to be the moment about the y-axis for this I thing. So I'm going to put an I here, and I'm also going to put a y. All right. Now, if you want to find out the moment, once you, this is just for this thing, right? Just for this bar. But I want the entire moment of not a rotation, the moment about the y-axis of the entire plane, this plane in here, okay? This metal plane, metal laminar something, I don't know. Metal plate, yeah. You want to know the entire thing about this metal plate. So you got to do this for xi, you got to do this for this, for this, for this. So all you got to do is to integrate, right? You're going to integrate this, and the number I is going to reach infinity. So it's the sum of I, when I is equal to 0, like it'll be the sum of this from I is equal to 0 to infinity, okay? So I is going to infinity, and delta xi is going to 0. So it'll just be the integral of x times f of x minus g of x dx, all right? And you're going to integrate it from, for example, from 0 all the way to, I don't know, b. Let's put a b in here. So you care up to this point. You don't care more than that point. Okay? But I'm going to take this b out of there. So it's going to be, for example, from 0 all the way to b, because it's about the y-axis. Okay, so you have to do that, and you also have to... So what are you having here? You multiplying the p times this stuff, which is the area. So now you have a mass, and this mass is going to have an x. And you go like, which one is going to be the x in here? Well, it depends. Actually, it's going to be all of them. This x in here is going to be this x for this plate, for this narrow rectangle. For this narrow rectangle is going to be another x. For this narrow rectangle is going to be another x. For this narrow rectangle here is going to be xi. Okay, so this is what you do. Now, what is the same thing around the x-axis? So if you have all these, all the infinite particles making up this thing here, okay, making up this metal plate, how are they gonna contribute together? How's the metal plate gonna contribute together to go about the x-axis? All right. There's just something else that I want to talk about the moment about the y-axis. So this is gonna be, I'm gonna do this here, guys, because it's becoming a real mess. Okay, up there. I'm gonna get this a little bit up. Okay, so I want this. Alright, putting it over here, kind of to the side. So you have P, alright, times this, which is going to be the integral of all this is going to be the area. So the density, the laminar density times the area is going to be the mass times the x. So this is going to be the moment, about the y-axis. Now let's just say that I want the moment about the x-axis, okay? You also need this thing here, and you're gonna do the integral, okay, also from 0 to b, and it's gonna be dx too. But here's the thing, f of x minus g of x, okay? I missed this one here. So I have this, f of x minus g of x times dx, all right? It's gonna give me the area just like in here, okay? And multiply that by p. I'm gonna get the mass, but now I have to get, for example, for this thing here, I gotta find the middle right here and find the distance from this to the x-axis. Okay, so I have to also multiply, I'm running out of space here. I'm gonna delete this. I'm gonna bring this stuff over. I'm running out of space. Oh. Sorry guys, it's just that I have to do this, okay? Here? Yeah, whatever. There. Now I'm gonna get the dx, I'm gonna bring it over here. Alright, so I have this thing times the dx, which is gonna give me the integral of this times the dx is going to give me the area times the density, the areal density or the laminar density, it'll get the entire mass. Now I need the mass for this thing here, for the middle point. And for example, for this bar here, the middle point is going to be here. For this bar here, the middle point's going to be here. For this one here, the middle point's going to be here. So I got to find this middle point. What is this middle point? Well, it's f of x plus g of x divided by 2. Okay, so I got to do like f of x plus g of x divided by 2. Since everything is multiplying in here, I can just put, okay, fine, I'll put it here. So this is going to be the moment about it's going to be the moment about the x-axis, and this is going to be the moment about the y-axis, and this is going to be the center of mass, the x-coordinate for the center of mass. The y-coordinate for the center of mass is going to be mx divided by m. Okay, if you don't know the density, you don't have to worry about it, because you see, what is m? I'm going to do m here. M equals the density times the area. Okay. All right. In the area is always going to be this stuff. Okay. The density. I think I had calculated the density here for you guys. Okay, I'll calculate the density again. Not the density, the mass. It'll be the density times the integral from f of x minus g of x dx. Okay, integrating with respect to x. What if I'm integrating with respect to y? Then you just change that stuff. Wherever it's f of x is going to be f of y. This x in here becomes a y. Okay, and this dx is going to be a dy. But then, yeah, or maybe this x is not going to be a y, okay, because it's going to be still an x, but as a function of y. You're not going to put a y here. You're going to have to put, because it's around the y thing, okay, because it's around this axis, what matters is the distance in x, not the distance in y. So you have to put this x as a function of y. For example, x equals y squared. So you're going to plug in y squared here. Okay, it's kind of like you have to deduce. I don't memorize these formulas. I work them out as I talk to you. And that's what you should do too. Never try to memorize these things because you're going to go crazy. So you see, if you don't know the density, you don't have to worry about it, because to find the center of mass x and y coordinates, it's going to be m about y divided by m. Well, m about y is this p here, and m also has this p, so this p is going to cancel with this one. All right. What about the y center? The y center of mass. It's also going to be m about x divided by m. So it's going to be this p simplifying with this p here. Okay. So you don't have to worry about the density if you don't have it. If you have it, that's fine, but if you don't, there's something else. If you don't have the density, if it doesn't really matter, because we just saw that it doesn't matter, then you can just consider the density 1. Oh, but the density is not 1. Don't worry about it. Don't worry about it, because you're going to be dividing anyway, okay? Of course, if you're not going to divide, if the intention of the exercise is not to find the center of mass x and y coordinates, if it's just to get up to here, and up to here, so you need this p, because you don't know necessarily that the density is 1, so you need it. But if you just want to find this stuff and this stuff, you don't even have to worry about the p, because when you do this division, they're going to cancel out. When you do this division, they're going to cancel out. For now, that's it, guys, and I'm going to leave the exercise for the next video, because this video is already getting too long and it's too much theory. Try to stuck this in your head, okay? Try to stick this in your head. I'm going crazy here. All right, see you guys on the next video.